If charged through 5 ports, the screen can display information from all 5 interfaces simultaneously. Chargers with screens are becoming increasingly popular. The Green Lotus Fast Display Charger supports 100. Today we will first evaluate and then disassemble to see how this charger. The package includes a 240W 1.5 meter braided data cable. The build quality of this cable is quite good. The plug has a metal casing, and the end of the cable is reinforced. The transition between the thick and thin parts is seamless, making it very resistant to bending. The charger itself has a matte finish, with a black panel on the side, and 5 USB-A ports, 4 USB-C ports, and 1 USB-A port. I personally prefer chargers with more features. In terms of charging protocols, it supports QC3, 0, Huawei ICP, Samsung AFC, and MTKPE, etc. For PD. Among the 5 fixed gears, one is AYS 920V5A, which is unique to PD3. 2. Below is PPS 100W, and more phones now support PPS. Finally, there's EPR at 140W. After testing, I found that the C2 port has the same protocol as the previous C port, while C3 and C4 ports are the same, supporting PD3, including voltage. The temperature gradient is displayed. Long press to rotate the screen. The current PD protocol output power is measured at 139W, while the screen shows 141W, which is quite accurate. Charging an iPhone 17 shows PD with a. Charging the Huawei Mate 80 Pro Max can reach 43W. Dual port output. When the C2 port is connected, the C1 port remains active. C1 port shows 94.7W. C2 port shows 57.7W with a total power of 153W. Of course, there will be some loss in the charging cable. The charger displays 157W. For 3-port output, when the C3 port is connected, C1 and C2 ports also remain active. Now charging through 5 ports, the total power is still 143W. In terms of temperature ripple, at 140W power, the ripple is only a few millivolts. At 100W power, it's also a few millivolts. At 65W power, it's 30 millivolts, and at 30W power, it's a few millivolts. The temperature ripple performance is excellent. Now, let's maintain a constant output of 140W for a while and observe the emission situation. It lasted for 4. The highest temperature is at the charging port, only 62 degrees. This temperature is very low, and this is measured at room temperature of 25 degrees. From another perspective, it seems the temperature control strategy is somewhat conservative. If set like most chargers with a temperature limit of around 70 degrees, it should be able to sustain output for an hour or two without issues. Now, let's open it up to see the internal workmanship. After opening, the inside of the shell. The main body currently only shows the screen and output interface part. Other internal components are covered tightly with thermal silicone grease. The bottom has a metal plate to enhance heat dissipation, with a layer. Spend some time cleaning the glue. Let's take a look. First, the small LCD screen board has a tiny MCU for screen display driving. The EMI filter board is rarely seen using 2 fuses. One is a conventional 250V5A fuse. Additionally, it has a temperature control switch with a limit of 65 degrees. Its principle is similar to the temperature control switch in a home electric kettle, which jumps when the water boils. 2-patch current bridge. This is a pi filter. On this large board, the fixed inductance uses flat wire inductors. Next is the PFC inductor, high-frequency transformer, and the high-voltage capacitor is covered with an insulating rubber sleeve. It uses a large capacity capacitor, quite thick. 450 volt. From Dongjia Electronics, there are 5 secondary solid-state filter capacitors, also from Dongjia Electronics. On the back, mainly looking at here, there are 2 InnoSys soft switching transistors forming a half-bridge structure. Next to it is an asymmetrical half-bridge controller. In the upper left corner is the PFC soft switching transistor, also from Inosys. This small board is the synchronous rectification controller and synchronous rectification MOS. Finally, C and C2 are two separate paths. C3, C4, and A port share another path. The protocol chips for C and C2 ports are from UGREEN. Additionally, there is a temperature probe placed at the dimming device position, along with the previously mentioned thermal hole switch, providing dual temperature protection, which is indeed very rare. The safety features are well done. In summary, the Green Lotus Fast Display Charger has solid workmanship, as you can see. It supports PD3, 140W, including 100W PPS. Generally, single-port 140W chargers do not exceed 100. The screen can also display information from 5 interfaces simultaneously. I think the screen on this Green Lotus model is quite intuitive. Additionally, the temperature ripple and temperature control